Hello everyone, today we are going to be solving another LeetCode question. This is find all anagrams in a string. So first, what is an anagram? An anagram is nothing but words which have rearranged letters. Example, rat and tar, ATM. In this you could see the letters are the same, but the arrangement of the letters is different. So this is what are called anagrams. And you have to observe another thing. The length of this and the characters in this are equal to the length of this and the characters in this. So this is one of the major thing that makes this an anagram. So first of all, you need to know how to check if one word is an anagram of other, and you can do this by counting the uh, different characters in that words. That is using a frequency count of letters. So that is rat and ATR. You would be counting how many R's are there in this, how many A's are there in this, and how many T's are there in this, and also you would be counting how many A's are in this, T's are in this, and R's are in this, and then comparing if these two are equal, then this is an anagram. If they are not equal, then this is not an anagram. And how would you be keeping track of this count? You could be you could either use a hash map or an array of size 26. Because in the question they said that there are only lowercase characters. So you could either use a hash map or an array. So with the basics done, let's just go into the brute force. So in this first, what you would be doing is getting a frequency count of all the characters in P. Then let me just write the S here. Then you would be iterating through S in the size of P. Okay, here P is this and size is 3. So you would be iterating through S in a size of P, that is 3. And for each substring, you would be finding the frequency count and comparing that with P. So first, you would be checking for the frequency count of CBA and comparing that with P. The both are equal, so you would be having an answer that is 0. I mean, you have to return the indices of start of indices of P's anagram in S. So that is the question. So that is what you would be doing. Then, after you are completed with the first window, this is what you would be doing is going to the second one, substring, and finding the frequency count of this and comparing that with P. This is not equal, so you would be moving forward, finding the frequency count of this substring, comparing with P. If that is not equal to P, you would be moving forward and you would be doing this until you get to here, where the frequency count of this substring is equal to the frequency count of P. So what you would be doing, you would be adding this index to the answer, and this is at what, 6th index. So after that you would also be moving forward, but you will not be able to have an anagram of this with this. So this is the answer. So in this, what we are doing is iterating from start to end of the array by taking the substring with the size of P. But while you are doing that, you are also finding the frequency count for each substring, right? So that takes a time of P, and you are doing this for S times. So our time complexity is P into S, where P is the size of the uh, string P and S is the size of the string S. This is our time complexity. And coming to space complexity, this would be O of 26, which would be O of 1, because we can remove the constants, right? So this is our space complexity. But can we do this in a faster way? The answer for that is yes. We could do this in a faster way, and I will be showing you how. So this is a problem of sliding window. Let me just try to spell it. Sliding window. So yeah. In the previous case, what we did was first find the frequency count of this, then again we found the frequency count of this, then again this from scratch. But if you see that the difference between this and this is just two elements. We are adding one, so we are removing one, and we are adding one. That's it. The other two remain the same. Okay. And when we go forward again, we are at here and here. We are removing one, we are adding one. That is all that is changing. So we have a window of size p that is going from start to end. At every iteration, we are removing one and we are adding one here. So that is what we are going to be using. So first we would be getting the size frequency count of p, and till here, that is size of p. We will be calculating these two frequency counts and storing those in the array. Let's just say array of s and array of p. This shows the frequency count of s and this shows the frequency count of p. We will be storing this in s and this in p. We will be comparing this. This is true. So we would be adding the index to our answer. Okay. So to say in a different way, we could say that we would be having two pointers, left and a right. So every time we move forward, we would be incrementing our left and also incrementing our right. While we are incrementing, we would be removing or decrementing the value of a left element and incrementing the value of our right element. Okay, so every time we move array of of s of left minus a minus minus, and we have a new element, right? So s of right minus a plus plus, and then what would we be doing? We would be comparing again array of s equals array of p. If this is true, we would be pushing left plus 1 to left to our answer. So this is the logic behind this problem. Now let's just get into the code. So the base case for this is if p dot size is greater than s dot size. So if the size of p is greater than s, then that will mean that we won't be able to create s with the elements that we have in p. Okay, we would not be able to create p with the elements that we have in s. So what we do, we would return just an integer. Okay, then let me just create two vectors to store my values. P of s, this is 26 and initialized to 0. And the same for the other one, and I will be naming this p. Okay, now what I am doing is first initializing the s and p arrays. Choose p plus and p of p of I minus a. What this does is gives us the true value because we are subtracting the ASCII value of a from the value of the lowercase letter. So this would be giving us a value in the range of 0 to 26. That is why we are doing this one. Plus plus. Similarly in this. This. Okay. This is for the first initialization. Then we check if mp of p equals mp of s. So before I do anything, let me just create a vector that stores my answer. Oops, like 0. Okay. Now this was for the initialization. This is creating the answer vector. And this would be the first case where we see this. That is the frequency count of p equals frequency count of s. Okay. Now let me just also have another variable for p size equals p dot size. Okay. Or p I equals 0 dot 0 I equals p size I less than s dot size I plus plus. Now what I would be doing is removing the value of this from the array of I minus p underscore size. Minus minus. Okay, did you get that? This is for removing the first, the first character in the substring. And then what we will be also doing is adding a character to this. I minus I plus plus. And now we will be checking. Okay? If s equals b of e, then insert the push back I minus p underscore size plus 1. And now we will be returning our answer. Let's just run this and see. So you can see this accepted. Let's just submit. So you could see this is the most optimal solution that is possible. You could now prefer the code. Thank you for watching.